Assalamualaikum and greetings to panel. My name is Muhammad Ridzlan bin Nazeri, student ID 2019685644. The title of my final year project is Design and Fabrication of Automated Karakuri for Large Packaging Box. There are several main contents for further explanation about my project. For quick understanding, I will go through project summary. Packaging process is a crucial process in manufacturing industry where the product is secured from any damage while being handled, stored and delivered. My final year project purposely to develop automated packaging system with implementation of Karakuri concept to practice lean manufacturing. There are several process and methodology involved to design the system as shown in this slide. For project background, packaging process is an important process involved in manufacturing industry to protect product from any damage while being handled, stored and delivered. Through this project, automated packaging process system for large packaging box has been selected to be developed with implementation of Karakuri concept to practice lean manufacturing. This project can lead to achieve Sustainable Development Goal 9, which is build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. This claim is due to implementation of Karakuri in developed system, since it is continuous development activities for further improvement. Furthermore, practicing lean manufacturing through this system will maximize resource utilization and reduce risk. For literature review, I have divided into 4 subtopics, which are Karakuri, lean manufacturing, Karakuri implementation case study, and packaging automation case study. Karakuri and lean manufacturing need to be deeply understood to optimize them in developing the system, while the case studies are required as reference for related design project and research gap identification. This slide shows some content of literature review included in this project, such as Karakuri make use of the natural principle like gravitational force to handle items, while lean manufacturing is designed initially to maximize the resource utilization and reduce waste. There are 4 problems that have been identified through this project, which are subsystems with their tasks that need to be identified, workability of concept design need to be checked, items need to be continuously supplied due to the automation, and limited usage of electronics component. First objective of this project is to study about Karakuri Kaizen to be implemented in packaging project system to enhance lean manufacturing process. Second objective is to design and fabricate efficient automated Karakuri for packaging process by using large packaging box. The scope of this project is to design and fabricate automated packaging system for large packaging box by implementing Karakuri concept to enhance lean manufacturing. Seesaw and pulley mechanism has been suggested to be used in the developed system. The packaging system will be based on the specified product, which is stationery and phone holder, that will be packed in a specified small box and finally into a specified large box as shown in figure in this slide. There are 3 limitations that have been identified. Firstly is limited space for the system to be developed and tested. Secondly is the cost required for initial investment for this project. Finally is the limitation to do performance evaluation on all concept design for comparison purpose, since the cost and period is limited. There are 5 methodologies involved in this project. First method used is gathering information to understand the related theories and generate design ideas for the developed packaging system. For theory, academic resources such as articles and journals have been used, while for design ideas, academic resources like articles and YouTube video have been explored. Second method is identifying physical decomposition of the automated packaging system. The system are divided into 4 subsystems, which are large box packaging process subsystem, large box inventory, subsystem to transfer small boxes into large box, and electronics component for automation assistant. The process of how the system will work is started when the small boxes consist of product are placed at specified area and then they will be transferred into large box. If the last box is fully filled with small boxes, the last box will go through the packaging process subsystem, and finally it will be transported onto trolley. Third method is concept evaluation, where morphological chart has been used. There are 6 features that has been listed in this chart, which consists minimum of 3 solutions for each features. After that, 3 concept ideas has been generated to be evaluated as shown in this slide. Fourth method used in this project is embodiment design, or known as preliminary design, which include the product architecture, configuration design, and parametric design for the developed system, followed with the last method, which is simulation of concept design through CAD software and prototyping. In this project, there are 3 expected results, and the first expected result is concept evaluation, where weighted decision matrix has been used to evaluate the best concept design to be developed. This evaluation results that concept design A has achieved the highest score compared to the other concept, hence this concept will be selected for this project. Next is the embodiment design. The embodiment design of the packaging system is shown as figures in this slide. The system design consists of subsystem to transfer small boxes to last box, which is colored as green, last box inventory, which is colored as blue with a little transparent, subsystem for packaging process of last box, which is colored as brown, and electronics component, which is in red color. The model design shown in this slide is the overall system with boxes, including the general dimensions. Referring to morphological chart, this design used solution 1 for large box, horizontal small boxes arrangement in large box, seesaw mechanism to transfer small boxes into large box, and prospect for large box inventory. For simulation, there are 2 simulations that have been used as mentioned in methodology, which are CAD software and prototyping. For CAD software, there are 3 simulations that have been done to demonstrate how the system will work. First simulation is to show how the last box will be placed at the design area. Firstly, the motor circle in the first figure will rotate to allow the last box to be moved to the specified area if there is no box at the area. Next, the last box in inventory will drop and move until it hits the motor, since it rotates back due to the existence of the box at the area. Next simulation is to demonstrate on how the small boxes are transferred into large box and then moved to packaging process. Firstly, when 3 small boxes are located as circled in first figure, the motor, which is circled in second figure, will leave the seesaw mechanism to cause the small boxes to move into a large box. This process will repeat one more time to fill the large box with 6 small boxes. After that, the pulley, which is circled in figure 3, will leave the large box until it hits the barrier to give decline angle, hence will allow the large box to move to packaging process subsystem. Last simulation is to simulate how the packaging process works. The last box will automatically move downward due to the decline roller used in the system. When the last box hits the lock, which is circled in figure 2, the box cap will be released and allow the last box to move downward with the box cap, hence result the complete last packaging box. For prototyping, there is only one simulation that has been done, which is to check the workability of the method to be implemented in the system to transfer small boxes into large box. For future activity, this project will go through a detailed design process, followed by fabrication of the system to complete this project. Next slide will show Gantt chart and all the references that have been used in this project. That's all from me. Thank you.